Hello everyone. Today we are going to talk about transport layer protocols. There are two very important ones in the transport layer protocol. One is our TCP and the other is UTP. Here, after receiving data from our application layer, it uses the transport layer to perform encapsulation. We've talked about encapsulation before, which is like if I want to deliver a package accurately to the other party's hands, then if it is delivered to the other party's city, the other party's community, then don't we also need to specify which building and which floor in that community? Here, we also need to establish an end-to-end connection. So what does end-to-end mean? It means application to application. Now let's say in this process, I have a computer here, and through the company's gateway device, I connect to the service provider. Through the service provider, I can access any website, web page, or any application. For example, now we open YouTube, open a website, and here, the YouTube website will respond to us. Besides this, if we are listening to music, the music platform will also respond to us. Apart from these, for instance, if we are using some social software, or other applications, we use X to represent them here. All of these will return to our computer, for example. Currently, my computer's IP address is 192.168.1.10. In the future, if we don't make any distinctions, the web response will return to the IP address 192.128.1.20. The music server will also return to 192.168.1.10, and X will also return to 192.18.110. We are all returning to the same place. So how does the computer distinguish which application it's for? The computer can't differentiate. So here we need to use an IP address along with a port to access it, for example. My web application has a port internally, and here we use 100 to represent it if we are talking about music here. Internally, my port for music is 200x, corresponding to a port of 300. So when I send it over, I will include, for example, if I am accessing the other party's web, I will use 192.168.1.10.100 to send to the web. When the web replies to me, it will also return to me saying it will send back to 192.168.1.10.100. Therefore, in this context, we access through the method of using an IP address along with a port. Now, in this process, can we choose the port number arbitrarily? Is it like we can use 100, 200, or 300 here? Actually, it's not like that. The port number actually has a range, and its range is from 0 to 65535. Among these, from 0 to 1023, these are well known and reserved in advance. This means that if most people need web pages, we might as well define port 80 to specifically provide external page services. There are quite a few of these well-known ports. For example, when we talked about the application layer before, FTP. FTP reserved port 21, Telnet reserved port 23, HTTP reserved port 80, and HTTPS reserved port 443. All of the above are ports reserved by TCP. Besides TCP, UDP also has some services. For example, DNS uses port 53. What about the port used by DHCP? It uses port 67 and 68. In this context, the services we want to access are the destination ports. This means accessing the IP of the other party, for example, port 2.2.2.2 in this context. What is it? It's 80. Now, what about my local source port? After all, I need to use my own IP along with a port to access the other party's IP and port. The IP address is something we will learn about later. It's something we configure or obtain automatically. As for the port number, like my local source port number, in this process, we randomly generate a high port number, meaning greater than 1023, because 0 to 10. 3 are our well-known ports. Now, aside from this, the destination port is fixed, so you don't need to worry if it's not a web page or a website, but some social media software. You don't need to worry about these. They worry that their destination ports are already pre-configured on their servers as TCP, which we refer to here as Transmission Control Protocol, and it is connection-oriented. In this process, for instance, if in the future everyone is on vacation, wants to visit friends, for example, one person is in the United States and another person is in Japan. At this time, if the friend in the United States wants to visit the friend in Japan, wouldn't they need to inform the other party in advance to avoid a wasted trip? To avoid arriving in Japan only to find that the Japanese friend has gone out? So in this process, they would first make a phone call. If the other party receives it and acknowledges it, then they know. I will be at home waiting for you then. At this point, they won't end up going there and finding no one at all. This is similar to how TCP works. Before I officially go to find you and officially send you data, I first establish this point-to-point connection, which is more reliable. As for our UDP, what is it called? It's called the User Datagram Protocol, and it is unreliable. I just go directly. As for whether you are there or not, well, I really don't know. This is the difference between reliable and unreliable. If you still don't understand, let me explain further. Let's give an example here. TCP, for instance, is like if I want to throw you a handful of candy right now. We stand face to face and I tell you that I am going to give you some candy. You hear it and say, okay, then I give it to you. I inform you in advance before giving it to you. As for UDP, what is it? UDP is like I don't tell you anything. I just throw the candy directly at you, whether you can catch it or not. Well, I don't care, and whether I hit you or not, I also don't care. So in this context, we say it's not very reliable. Now, regarding reliability and unreliability, it actually depends on something, and it's not as simple as we are discussing today. If we talk about it here, it relates to the form of data encapsulation. Look, if in the future we have some data, and after this data is generated here, it will add our TCP in front of it, or a UDP encapsulation, and what follows is our actual data. Now, what will be inside this TCP or UDP encapsulation? Let's look at this large section, which is our TCP encapsulation. As for the UDP encapsulation, it's only this small part. First, we need to mark the source port and destination port, since we are transmitting using the IP plus port format. Now, within this, the source port refers to my own port, and the destination port refers to the other party's port. Next is the sequence number. The sequence number is used during network transmission to ensure that each piece of data has a sequence number for acknowledgement. As for acknowledgement here, it is also used for confirmation. We will discuss the role of these two when we talk about the TCP three-way handshake. Then, within this, we also have our header length. Here, the TCP header, which means the outer shell that we will encapsulate E. In the future, how large is it specifically? The receive is reserved, meaning this field is kept in reserve in case we need to add new features in the future. Following that are our control bits, among which there are 3 types. They are FIN, ACK, and our SYN. Of course, there are more than 3 types, but here we focus mainly on these 3, and I will describe them to you later. There's also the window size, QR. This is used for flow control, indicating the maximum segment size allowed by the receiver. The checksum is used to verify whether any issues occurred during transmission over the network. You see? Apart from this, the remaining parameters do not require our attention. This is in preparation for learning a technology called QS later on. Besides this, there are also some optional fields. This is the header of our TCP. Apart from the optional fields, these are a total of 20 bytes, and they must include these headers. The UDP header below is relatively simple, consisting only of the source port and destination port, meaning what my port is and what the other party's port is, as well as the overall length. Additionally, it includes a checksum to verify whether any errors occurred during data transmission. This kind of verification, aside from these, is just our data, and its encapsulation is relatively minimal. So how does TCP achieve reliable transmissions? Hi? It relies on the TCP three-way handshakes. As for the TCP three-way handshake, alright, we'll discuss it in the next lesson. If anyone wants to learn Huawei certification technology or obtain the Huawei certification question bank, please send a private message. You can also leave a comment below the video.